Hi, 7th graders, and welcome to lesson 8.4b, proportional relationship equations. In this lesson, we're going to look again at the y equals kx equation, which is the equation of every directly proportional relationship. Let's first begin by reviewing what we know about a directly proportional relationship. So we're going to take a look at this example. Can you go ahead and fill in the table with these values in your notes? And once you have the table filled in, we're going to go ahead and plot these coordinates on our coordinate plane. So remember, here we have an ordered pair, -2, 1, and we're just going to go ahead and graph that and make a point. And of course, we've got 0, 0 because all directly proportional relationships go through the origin at 0, 0. 2, -1, 4, -2, and lastly 6. All the way over to 6 and down to -3. Then just go ahead and take a moment and draw a straight line through your points. And you can see here that the graph is a straight line, and of course it goes through the origin. So over here on the left, let's just go ahead and write that. We have a straight line. And it goes through the point 0, 0, which is the origin. Now let's go ahead and take a look at the constant pattern that we see in the numbers in the table. Remember, with all directly proportional relationships, we're going to see a pattern that's y over x, and that's our slope. So let's go ahead and take a look at all of the y over x ratios. We've got 1 over -2. 0, 0 doesn't really count. Can't write that as a fraction. -1 over 2. -2 over 4. And -3 over 6. Do you see how all of these are equivalent? They're all exactly the same fraction. They are all equal to -1/2. And we should always see that y over x relationship anytime you have a directly proportional relationship. So now let's go ahead and find the slope from our graph. So remember, slope is the ratio of rise to run. So we're just going to look at our points, and we can see our vertical change. Our rise is 1 unit, and our run is 2 units in the left direction. So we've got rise of 1, run of 2, rise of 1, run of 2. So we can go ahead and write that as a ratio. Our rise, our vertical change is 1, and our run, or horizontal change, is 2, and we can see that this is a negative slope. If I was walking along, I would be going downhill. So we want to put a negative sign in front of there. So we have a slope of -1/2. Now notice here that the y over x pattern and the slope, those two are exactly the same number. They should be. Now let's go ahead and write the equation for this relationship. We learned yesterday in lesson 8.4a that all directly proportional relationships all have the same equation, y equals k times x. And that k right there, that is the slope. So if we know that the slope of the line is -1/2, then we can write the equation for this. Y equals -1/2 times x. And there we have the equation for this relationship. So those are all of the characteristics we've been learning about directly proportional relationships. Now, one of our first goals today is going to be, how do we write a directly proportional equation from a graph? So here I'm giving you a graph. We can see it's directly proportional, straight line through the 0, through the origin. And what I'd like you to do is to be able to write an equation. Now we know that all directly proportional equations look like this, y equals k times x, and that k is the slope. So as long as we find the slope of this line, we're going to be able to write our equation. So remember, slope is that ratio of rise to run. So if I start here, this is a point 0, 0. If I rise up and run over, I land at another point on the line. So let's take a look at our rise. We see that we're counting by 20s on the y-axis and by 4s on the x-axis. So when we rise up 1 unit, we're actually rising up 20. And then when we run across from 0 to 4, that's a run of 4, and that continues. We rise up another 20, and we run 4. So let's write the slope as the ratio of rise to run. Rise is 20, and the run is 4. And of course, this can be simplified. 20 divided by 4 is equal to 5. So 5 being our slope, we're ready to write the equation. Y equals k, which is our slope, is 5, so y equals 5 times x. And that would be the equation of this line. Let's look at the next one. Here we have the y-axis counting by 50s, the x-axis counting by 30s. So we have to keep that in mind when we find the slope. Here's the origin point, and we've got several other points on the line we can use. Let's go ahead and find the rise. From a 0 up to 50, we have a rise of 50. And if you look at the run from 0 to 30, that's a run of 30. And that continues. Rise 50, run 30. Rise 50, run 30. So let's write the ratio of rise of 50 to run of 30. And of course, you have to have it simplified. And we know that 50 and 30 are both divisible by 10 because they end in zeros. So 50 divided by 10, 30 divided by 10, and we have a slope of 5/3. So let's use that slope to write the equation. Y equals slope, which is our k, times x. And there's the equation of our directly proportional relationship in that one. All right, let's try another one, see if we've got this. Okay, looks like on this one, we've got the y-axis counting up by 2's, and we've got the x-axis over here counting by 6's. This is comparing the weight in pounds on the Earth versus the moon. So let's go ahead and find our slope. Here's our 0, 0. And looks like we can rise up, halfway between 0 and 2, and then we have to run over to get to the next point on our line. So it looks like from 0 up here, this is 1 unit. And then when we run from 0 to 6, that's a run of 6 units. Again, up 1 over 6, up 1 over 6. So it looks like our slope would be a rise of 1 and a run of 6. Using that slope, we'll write our equation. Y equals 1/6 times x. And there we have our equation. Let's go ahead and do the same one on this last one here. Here we've got hours and total cost. We've got a few points on that line. We can always use the 0, 0. But looks like the y-axis counting by 24s, the x-axis is counting by 1s. So when we rise and run over to this next point on the line, the rise from 0 to 24 is a rise of 24. And then when we run, look at where we run. We run across here, 0 to 2. That's a run of 2. Okay, that continues. We have another rise of 24 and a run of 2. So let's write the slope. Rise of 24 and a run of 2. But 24 divided by 2 is the same thing as 12. So we want to be sure we have that simplified. The equation would be y equals slope times x. Y equals 12x. Notice that both of the slopes here are positive numbers, and we see that both of the graphs go straight up and they increase. They both have positive slopes. All right, our next goal is going to be how do we write a directly proportional equation from a table. So here in these next 3 examples, I'm going to give you a table of x and y coordinates, and I'm telling you that it's directly proportional, and I'd like you to write the equation. Remember, the equation of a directly proportional relationship is y equals k times x, where that k is the slope. But we also know that slope is our y over x pattern. So knowing that slope is y over x, that's going to be our k. So all I have to do is figure out what is the y divided by x pattern in the table. That will give me my slope. So let's take a look at what we have here. We have y over x, 8 over 6. I'm going to write that. We have 12 over 9, 20 over 15. All right, now let's take a look at simplifying each one of these. They should all be the same. They should be equal. So if I divide the 8 and the 6 both by 2, that would give me 4/3. If we divide 12 and 9 both by 3, that would also give you 4/3. And if you divided 20 and 15 both by 5, you would also get 4/3. So all 3 simplify to 4/3. So 4/3 is the y over x pattern, which is also the slope and the k. So let's write the equation. Y equals 4/3 times x. And there's the equation that represents this table. So if we were to plot these points on the coordinate plane and draw a straight line, it would have a slope of 4/3. Remember, slopes always need to be simplified. Okay, let's look at the middle one here. Again, a directly proportional relationship, so we should see y over x pattern. So if I take y over x, 30 over negative 6, 10 over negative 2, and 15 over negative 3, these should all be equivalent. They're all the same. Well, none of them are simplified. So you can take any one of them and go ahead and simplify it. Let's take the middle one, negative 10 halves. What is negative 10 divided by 2? Well, of course, it's negative 5. All three of these simplify to negative 5 because we know negative 30 divided by 6 is negative 5, and so is negative 15 divided by 3. So that means that the y over x pattern, which is the slope, is negative 5. Let's use it to write our equation. Y equals negative 5 times x. And that's the equation for that proportional relationship. Let's do one more. Now, we know that every y divided by x in this table is going to be exactly the same. So you really only have to take one. Maybe you pick the one that has positive numbers. And let's write y over x, 8 over 28. Then we can go ahead and simplify this. An 8 and a 28 are both divisible by 4. So 8 divided by 4 is 2, and 28 divided by 4 is 7. So I would have a slope of 2/7. So I could write the equation y equals 2/7 x. Okay, I only need to use one because all of the y divided by x patterns are going to be exactly the same. Let's move on to our last goal for this lesson. Our last goal here is how do you graph a directly proportional relationship if you're given an equation? So in these two examples, the two equations I'm giving you are very similar. The only difference is that this one happens to be negative. So let's take a look at what we know. Do you remember that our directly proportional relationship equation is y equals k times x? And k, we know, is the slope. Well, if you take a look at this first equation, it says y equals x, and there's no number in front of the x. Well, what number is it? It's invisible. Now think about if we had a number in front of the x like 3x, if it said 3x, we know that the slope would be 3. And if we had a 2 in front of there, we would know that the slope would be 2. But what if we just have an x? What invisible coefficient is in front of the x? Ah, you're right, it's a 1. 1 times x. Isn't that just x? Absolutely. So let's go ahead and put the 1 in front. That is your slope. It's 1 times x. So now that we know that the slope is 1, let's go ahead and try and graph this line. Well, what do we know about every directly proportional relationship when you look at a graph? It always goes through the point 0, 0. So we know that 0, 0 has to be a point on the graph. Now this line that I make has to have a slope of 1, which means being that slope is rise over run, it would have to have a rise of 1 and a run of 1. So if I have to have this line going through the origin, I know I can start with this point right here, and I can make some additional points using that slope. Let's go ahead and rise up 1 and run over 1 to the right and make another point. Let's do the same thing. Rise up 1, run 1. Up 1, run 1. Up 1, run 1. I can still do that in the opposite direction. I could fall 1 and go back 1. Fall 1 and go back 1. I've got lots of points on this line. I think I'm ready to draw it. There's my line. Now notice two things about this equation when it's graphed. It goes through the 0, 0 because it's a directly proportional equation, and it also has a slope of 1. Rise, run 1, and run 1 simplifies to a slope of 1. And we did it. Now how is this one going to be different? Do you see here how this says negative x? Just like if it was negative 3x, the slope would be negative 3. Or if it was negative 2x, the slope would be negative 2. What about if it's just negative x? What invisible coefficient is in front of the x? You guessed it, it's negative 1. So that means our slope is negative 1. Now the only difference is this is going to be a negative slope. It's still going to have the same rise and run. Because remember, the rise would have to be 1 and the run would have to be 1 for it to simplify to give you negative 1. So we know that it has to go through the origin. Let's start by plotting a point there, and we're going to make some additional points using that slope. So being that it's negative, I could rise 1 and run 1 to the left in the negative direction. I could rise 1 and run 1 to the left. Also being that it's negative, I could fall 1 and run to the right. Falling is a negative move, and run 1 to the right. Now, when I go ahead and connect those points, 2 things I'm going to notice. The line goes to the origin like it should, and it has a slope of -1. Rise 1 and run 1 to the left, and the line is falling. And there we've got it. Let's try it with a couple other slopes. So let's take a look at this example where we have y equals 3/4 x. Now we know that 3/4, that is going to be our slope. And we know that slope is rise over run. Being that this is a directly proportional relationship, it's in the form of y equals kx, we know that the line has to go through the origin 0, 0. So that can be our starting point. Let's put that point on here because we know that that's a for sure. Now we're going to need some additional points. Being that we have a slope of 3/4, that means we have a rise of 3 and a run of 4. So from this point, let's go ahead and rise up 3 units, and then we're going to run 4 in the positive direction to the right. 1, 2, 3, 4, and make a point. All we need is 2 points to create a line. So if I draw a line through here, I've got my 2 points. This one goes to the origin, showing a directly proportional relationship, and we can see that this has a slope of 3/4 because I checked it right there. And this would be your line. What about this one where it says y equals 2x? What's the slope on this one? You guessed it, it's 2. Now remember, with the slope, we need a ratio of rise to run. And we only see one number. It's 2. Can we make 2 into a fraction? You bet we can. 2 over 1. Any number can be written as a fraction with 1 as the denominator. So let's do what we did before. We're going to start at the point 0, 0. And now we're going to make some additional points using that slope. So start at your 0, 0. Let's do rise of 2. Whoop, 2 up. And we're going to run 1 to the right. Let's do it again. Rise 2, 1 to the right. Now when you go ahead and connect those points, you're going to see a steep slope. Goes through the 0, 0. We got a nice slope of 2. Rise 2, run 1. Rise 2, run 1. We can check it. Very good. Now both of these had positive slopes. What would happen now if we took a look at a negative slope? This might be kind of hard to see. It says y equals -4/5 x. So there you can see that just a little bit better. The font makes it kind of hard to see. So our slope is -4/5. Okay, let's do it. We know slope is rise over run. We know that this is a directly proportional relationship, so it has to go through 0, 0. So let's start at 0, 0. There's our first point. Let's make some additional points using the slope. Now we want a negative slope. So we could rise up 4, 1, 2, 3, 4, and then we have to run 5. But to make it a negative slope, we would have to run 5 in the negative direction. 1, 2, 3, 4, 5, and make another point. Another way to look at this is instead of rising, we can fall 4. So our vertical change could be falling 4, but then we'd have to run to the right. 1, 2, 3, 4, 5, and we could have a point there. So now that we have 3 points and they're all evenly spaced here, we can go ahead and connect them, make our line, and we see how we have that negative slope. And if we grab any 2 points, we can see it's a rise of 4 and a run of 5, and it's negative. Getting a little bit more challenging here. -3 slope. How are you going to graph that one? Start at your origin. That's got to be one of the points on the line. Let's go ahead and write this as a fraction over 1. Now we want a negative slope. So we can still rise 3, but if we run, it's got to be negative. We'll have to run 1 in the negative direction to make this line fall. Otherwise, we can look at this negative as a fall instead of a rise. We can fall 3 units and run 1 to the right. And then when we connect the points, we'll see that we have a very steep, look at that, going downhill, very steep negative slope going through the origin. How cool is that? Let's see if we can answer this question. How can I tell if an equation is directly proportional? So I'm asking you here, let's have you circle which equations are directly proportional. Maybe pause the video and give it a try. So what do we know about directly proportional equations? They're always in the form of y equals k times x, where k is our slope. That's the only way that they can be written. So let's take a look at these 4 equations. Which ones are written in that form? Well, if you take a look, this first one is, do you see how it says y equals 1/3 times x? the 1/3 would be the slope. So this is absolutely correct. Take a look down here. Do you see this is y equals -4 times x? Right here, -4 would be the slope. It would be a negative slope. That one's also written in the form. Why are these two not directly proportional? Well, do you see right here? This would be directly proportional if this were a 0. If we were covering this up, now it's directly proportional. But being that there's a +3, that makes it not directly proportional. When we look at this form, we can't have anything added or subtracted to it. So this one is not directly proportional. What do we notice here? This is division. This is y equals 24 divided by x. This would be an inversely proportional relationship. So nope, can't have that one either. These two would be directly proportional. So here's a question for you. What if I had an equation y equals 2x plus b? And I wanted to ask you, what would the value of b have to be in order for this to be a directly proportional relationship? Well, if we want it to look like this, there couldn't be any number here. This would have to be nothing. So what number represents nothing? That would be 0. If we had y equals 2x plus 0, then we would have a directly proportional relationship. B would need to be a 0, so it would go away, and we would just have an equation that looks like this. All right, let's go ahead and go to our summary. So in your summary, the equation y equals kx, write that here, represents directly proportional relationships, where k is the slope of the line. And we also know that slope and rate of change are the same thing. So when we see an equation in this form, it's directly proportional, and that number right there is our slope. Thank you for joining me for lesson 8.4b. Have a great day.